Hello and welcome to your Properties of Water notes. Today we're going to explore the unique chemistry of water and how it gives it its amazing properties. So let's talk about the importance of water. Water, or H2O, is an inorganic compound found in all living things. It supports all life without being living. Living cells are made up of 70 to 95% water, and water covers 75% of all of Earth. Water exists in three physical states. It can either be a solid, like ice, a liquid, like the water as we know it, or a gas, like water vapor. So, we said water is H2O. That's two H's, two hydrogens, and one oxygen. Water is a polar molecule. This means that one side of water has a slightly positive charge and the other side of water has a slightly negative charge, or opposite charges. Think about someone who maybe has bipolar disorder. They have opposite emotions. Or you might say someone is a polar opposite to you. It means that they are very different. The same is true of a polar molecule. They have opposite ends, have opposite charges. Oxygen is really big. I like to think of the O in oxygen as a 0 on a test or an assignment, which is very negative. That's because oxygen grabs electrons, which are negative, making oxygen a slightly negative molecule. Hydrogen is happy. H, happy. So those have positive charges. So the oxygen end is negative and the hydrogen end is positive. How does water stick together? So, because negative and positive charges is the same as a magnet. So, water can stick to not only water through its negative and positive charges, but also other things. Positive attracts negative. Opposites attract. So, water is almost magnetic. This magnetic bond between water and other water molecules is called a hydrogen bond. A happy hydrogen, positive, bonds to a negative oxygen. Hydrogen bonds are always between a hydrogen of one molecule and the oxygen of another. Because of this specific type of polarity, water has a lot of magical properties. We're going to go through all 5 in today's slides. The first property is specific heat. Water, because it forms those additional hydrogen bonds, takes a lot of energy for it to change temperature. That means water does not like to heat up and it doesn't like to cool down. This is really good for living things because, as we mentioned earlier, living things are mostly composed of water. You don't want to accidentally step outside on a hot day and you're boiling from the inside out. But you also don't want to step outside on a cold day and start freezing from the inside out. Water helps you regulate your body temperature. So, when we said water is magnetic, we can also call water sticky. It sticks to things because of its magnetic properties. There are 4 sub-properties that are because of this stickiness. The first is cohesion. Cohesion means that water sticks to water. Co means together. Just like you most likely have a co-teacher in your classroom. They stick together. Water sticks to water. When it does this, it can actually form a bit of a skin or barrier on the surface of water that allows things like bugs to stand on it. We call this surface tension. It can support light weights because of those hydrogen bonds at the surface, water sticking to water. Adhesion, adhesion meaning sticking, water is adding itself to something else. So water might stick to a table or it might stick to your shirt. This is adhesion, water sticking to something else. Because of this, water sticking to itself and sticking to other things, water is able to climb up narrow tubes. We call this capillary action. Capillary action is when water links arms with itself and the outside arms of the water start climbing up the tube. You might see this in a straw in your cup. You'll see that the water line in the straw is slightly above the water line of your cup. This is cohesion and capillary action. Where you might see this in nature is how plants get water all the way from their roots up to the very top leaves of their tree. Capillary action is when water climbs up a thin tube. Density. Water can actually change its density depending on which state it's in. Remember, water has 3 states: solid, liquid, and gas. When water freezes, it starts to expand, and therefore it takes up more space, making it less dense, because the weight of water does not change, but the space it takes up does. That is why ice floats on water, because ice is less dense than water. For example, I weigh 160 pounds, and I am 5'3". I have a brother who also weighs 160 pounds, but he's 5'11". Which one of us is more dense? If you answered me, you're correct. I am more dense because I have more weight in a smaller size, whereas my brother has more weight in a larger size. My brother is more likely to float on water than I am, because the less dense something is means that it's more likely to float. Water is also a universal solvent. If you've ever made a mixture in your cup, so maybe you were mixing sodas or juices, or maybe you were making Gatorade from powder or Kool-Aid from powder, you will notice that water is able to dissolve things like powders and sugars. That's because water is a universal solvent. When we're talking about universal solvents, you need to know a couple vocabulary words. First, a solvent is the thing that does the dissolving. That's water in this case. A solute is the thing that is being dissolved. So your Gatorade powder. Once you mix the two together, your water and your powder, or your solvent and your solute, you now have a solution. A solution is the mixture of substances. Water being polar means that water can dissolve any other substance that is polar. So, water has a positive and a negative end. If something is hydrophilic, it means that it's water loving. If something that's hydrophobic, it means it's water fearing, and it's probably not going to dissolve in water. When you hear hydrophobic, think phobia, fear. Water also has a neutral pH, which is a pH of 7. pH stands for percent hydrogen. This scale tells you how acidic or how basic something is. So with water being neutral at 7, the strongest acid is a 0, like battery acid. I like to remember this as acids are small. So acidic solutions have pHs that are smaller than 7. Bases go up to 14. Bases are things like bleach is a base, which has a pH of about 12. Bases are big and basic. Bases have a pH of anything over 7. Water, being neutral, is neither acidic nor basic. So, think of all the things in your home. Every solution or item you have in your home has a pH. Things that are neutral are your water. Milk is slightly acidic. Baking soda and soap are slightly basic. You might even have strong things like bleach, which has a pH of 12. That's a strong base. Or maybe you use lemons when you're cooking or putting it in your water. That's a pretty strong acid.